Hello viewers, welcome back to my YouTube channel. In this video I am going to discuss about the types of antenna and its applications. And the introduction to antennas. Antennas are devices that converts electrical signals into electromagnetic waves and vice versa. They are essentially components in communication systems for transmitting and receiving signals. Antennas comes in various types, each designed for specific applications. And the dipole antennas. A dipole antenna consists of two conductivity elements allied in straight lines. It is widely used for radio and television broadcasting due to omnidirectional radiation pattern. Dipole antennas are also commonly used in wireless local area network applications. And the Yagi-Udo antenna. The Yagi-Udo antenna is a directional antenna with multiple elements arrangement in a specific configuration. It is commonly used for long distance communication and TV receptions. Yagi-Uda antennas are also used in radar systems for their high gain and directivities. And the patch antenna. Patch antennas are compact and lightweight antennas with a flat radiation element. They are commonly used in satellite communication, GPS systems, and wireless communication devices. Patch antennas are preferred for low profile and ease of integration into electronic devices. And the parabolic reflector antennas. Parabolic reflector antennas use a curved disc to focus radio waves onto a single point. They are commonly used in satellite communication, microwave links, and radar systems. Parabolic reflector antennas offers high gain and narrow beam width for long distance communication. And next, helical antenna. Helical antennas are spiral shaped antennas that radiate circularly polarized waves. They are used in satellite communication, RFID systems, and mobile communications. Helical antennas are preferred for their compact size and ability to provide stable signal reception in changing environment. And the log periodic antennas. Log periodic antennas have a series of dipole elements with vary length. They are used for wideband applications such as TV antennas and spectrum monitoring. Log periodic antennas offer consistent performance across a broad frequency range. And the antennas. Horn antennas have a pyramidal or a conical shape with a flared opening. They are used for microwave communication, radar systems, and EMC testings. Horn antennas offer high directivity and low side lobes of precise signal transmissions and receptions. And the log loop antennas. Loop antennas consist of one or more loops or wire or conductors. They are used in AM radio broadcasting, RFID systems, and metal detectors. Loop antennas are compact, lightweight, and offers good performance in limited space applications. And the microstrips antennas. Microstrip antennas are fabricated on a printed circuit board using microstrip technology. They are used in mobile phones, WLAN systems, and satellite communication. Microstrip antennas offers low profile, lightweight designs and ease of integration into electronic devices. And next one, antenna arrays. Antenna arrays consist of multiple antennas arranged in a specific configuration. They are used to increase gain, directivity, and signal diversity in communication systems. Antenna arrays are commonly used in radar systems, base stations, and beam forming applications. And the smart antennas use signal processing techniques to adapt the antenna's radiation pattern dynamically. They are used in wireless communication systems to mitigate interference and improve signal quality. Smart antennas offers enhanced performance, increased capacity, and better coverage in mobile communication networks. And the antenna diversity. It involves using multiple antennas to improve signal reliability in a fading environment. It helps to overcome multipath fading and enhance the quality of wireless communication. And the antenna diversity is commonly implemented in mobile phones, WLAN systems, and IoT devices. And the emerging antenna technologies, metamaterial antennas, fractal antennas, and reconfigurable antennas are examples of emerging antennas technologies. These antennas offers unique properties such as wideband operation, tunabilities, and miniaturizations. Emerging antennas technologies have the potential to revolutionization communication systems and enable new applications. And this was about the video. And conclusion, antenna plays a crucial role in modern communication systems for transmitting and receiving signals. Understanding the different types of antennas and their application is essential for designing efficient communication networks. As technology advances, new antenna designs and technologies will continue to drive innovation in the field of wireless communication. Hello viewers, welcome back to my YouTube channel. In this video, I am going to discuss about the analyze various biomass conversion technologies and the introduction to biomass conversion technologies. Biomass conversion technologies plays a crucial role in converting organic materials into useful energy sources. These technologies help reduce greenhouse gas emissions and promote sustainable energy productions. And the combustion is a widely used biomass conversion technologies that involves burning biomass to produce heat or electricity. It is a relatively simple and cost efficient process that can utilize various types of biomass feedstocks. And the gasification is the thermochemical process that converts biomass into synthesis gas, contains carbon monoxide, hydrogen and methane. The synthesis gas can be used for power generation, biofuels productions and chemical synthesis. And the gasification technologies offers a high efficiency and flexibility in utilizing different biomass feedstocks. And the pyrolysis is a thermal decomposition process that converts biomass into bio-oil and synthesis gas. Bio-oil produces through pyrolysis and can be used as a renewable fuel for heat and power generation. Pyrolysis technology is well suited for processing agricultural, forestry waste and municipal solid waste. And the anaerobic digestions. Anaerobic digestion is a biological process that breaks down organic materials in the absence of oxygen to produce biogas and distillate. Biogas generated for anaerobic digestions can be used for heat and power generations or upgraded to biomethane for vehicle fuels. And the fermentations is a biochemical process that converts sugars in biomass feedstocks into biofuels such as ethanol and biobutanol. Fermentation technologies is widely used in the production of bioethanol from sugarcane, corn and etc. Hydrothermal hydrothermal carbonization. Hydrothermal carbonization is a thermal conversion process that transforms wet biomass into hydrochars through high temperature and pressure. This technology is suitable for processing wet biomass feedstocks like sewage, algae and organic residues. And the torrefications is a thermal pre-treatment process that thermally decomposes biomass at moderate temperatures in the absence of oxygen. Torrefaction technology can be enhance the quality and storage stability of biomass for combustion and gasification applications. And the direct combustions versus co-firing. Combustions involves burning biomass as the sole fuel source to produce heat or electricity in dedicated biomass power plant. Both direct combustions and co-firing are important biomass conversion technologies for transitioning to a low carbon energy future. And the challenges and opportunities in biomass conversion. Challenges in biomass conversion technologies includes feedstock availability, technology efficiency, and economic viability. And the collaboration between policymakers, industry stakeholders, and researchers is essential to overcome challenges and promote the sustainability growth of biomass conversion technologies. And the environmental benefits of biomass conversions. Biomass Biomass conversion technologies offer significant environmental benefits by reducing greenhouse gas emissions, promoting resources efficiency, and supporting rural development. By converting biomass into valuable energy products, these technologies contribute to a more sustainable and energy systems. And the economic considerations in biomass conversion. The economic viability of biomass conversion technologies depends on factors such as feedback cost, technology efficiency, government intensities, and market demand. Investments in biomass conversion products can lead to job creations, rural development, and energy security. And the future trends in biomass conversions. Future trends in biomass conversion includes the development of advanced conversion process, integration with other renewable energy systems, and scaling up commercial development. Research and innovations in biomass conversion are focused on increasing efficiency, reducing cost, and improving environmental process. And case studies of successful biomass conversion projects. Example includes biomass power plants and integrated energy systems that demonstrate the economic and environmental potentials of biomass conversions. Learning from successful projects can inspire further investments, innovations, and collaboration in the biomass conversion sector. And conclusions. Biomass conversion technologies plays a crucial role in transitioning to sustainable energy future by utilizing organic materials to produce renewable energy. Collaboration, innovations, and policy support are essential for advancing biomass conversion technologies and achieving a more sustainable, low carbon. And hello viewers, welcome back to my YouTube channel. In this video, I am going to discuss why do some business plans fails and the procedures for setting up an entrepreneurs. And the introduction. Business plans are crucial for success of any enterprise. However, many business plans fails due to various reasons. Understanding the common pitfalls can help entrepreneurs avoid failures. And the lack of market research is one of the main failure to conduct through market research can lead to mismatch between the product or service and the target market. Without a clear understanding of customers needs and industry trends, a business may struggle to attract customers. Market research is essential for identifying opportunities and risks. Inadequate financial planning. Poor financial planning, including underestimated costs and overestimated revenues, can quickly financial distress. And the lack of contingency plans for unexpected expenses or market fluctuations can business stabilities. Successful business priorities financial planning and regularly review and adjust their financial strategies. And lack of clear objectives. Business plans that lack clear, measurable objectives can result in a lack of direction and focus. Without specific goals and milestone, it can be challenged to track progress and make informed decisions. Successful business plans set smart objectives to guide the organizations, and the poor executions. Even the most well thought out business plans can fail if not executed effectively. Inadequate leadership, inefficient process, and lack of accountability can hinder successful implementation. Strong execution requires effective communication, teamwork, and a focus on continuous improvements. And ignorance, competition, failing to access and understand the competitive landscape can leave business to competitive. Ignoring competitors' strengths and weakness can result in missed opportunities and competitive threats. Businesses must conduct competitive analysis to differentiate themselves and develop strategies for sustainable growth. And insufficient marketing strategies. A lack of comprehensive marketing strategies can lead to poor brand visibility and limited customer reach. Ineffective marketing efforts can result in low sales and market penetrations. And poor risk management. Businesses that fails to identify and mitigate risk are more uh, sus- susceptible and to unexpected challenges and setbacks. Successful businesses proactively identify access and manages risk to safeguard their operation and reputations. And lack of adaptability. In today's rapidly changing business environment, businesses that fails to adapt to market trends and customer preferences risk becomes and the resistance to change outdated process and can hinder innovations and growth. And ineffective leaderships. Strong leadership is essential for driving business success and a positive organization culture. Successful business prioritizes leadership development, mentorship, and creating a supportive and inclusive work environment. And at the end of the video conclusion, while business plans can fail for various reasons, understanding and addressing common pitfalls can increase the livelihood of success. By conducting throughout market research, prioritization, financial planning, setting clear objectives, and focusing on executions, businesses can mitigate risk and drive growth. And successful enterprises are built on a foundation of strategic planning, adaptability, strong leadership, and a customer centric approach. Hello viewers, welcome back to my YouTube channel. In this video I am going to discuss about how to create a student database using dictionary and pandas data frame in Python. And the introduction to student database. In Python, creating a student database involves using dictionaries and pandas data frames. The database includes information such as name, USN's semester, marks cards, and grades. Using dictionaries allows for easy storage and retrieval of student data. And the setting up the environment. Import the necessary libraries and pandas. Create an empty dictionaries to store student information. Initialize the pandas data frame with the dictionaries. And adding student database. Add student details to the dictionaries using keywords for name, USN, semester, marks, and grades. Appended the dictionary to the pandas data frame using the append function. Repeat the process for each student to build the database. And this is a Python program. The import pandas as PD, and the output. And for displaying the student database, use the head function to display the first few rows of the student database. Customize the display by selecting specific columns or rows. Utilize Panda functions to filter, sort, and manipulate the data. And the accessing student information, retrieve specific student details by querying the data frames based on criteria. Use conditional statements to filter data based on marks, grades, and other or attributes. And for updating student records, modify student information by updating values in the data frame. Use LOC or ILOC to access the change specific cells in the data frame. Ensure data integrity by validating and sanitizing inputs before updating. And for calculating grades, define a function to calculate grades based on marks obtained, and apply the functions to each rows in the data frames to assign grades, and update the data frames with the calculated grades for each students. And for exporting data, save the student database to the CSV files for future reference, and maintain data integrity and structures during the export process. And for the data visualizations, generate bar charts, pie charts, or scatter plots to represent data, or use a matplotlib or a seaborn to create visualization of student performance, and to enhance data analysis and presentation through effective visualization. And for handling missing data, identify and handle missing values in the student database. Use Panda functions like dropna and fillna to manage missing data. Implement strategies such as mean imputations or interpolation to fill missing values. And for sorting and filtering, sort students records based on specific columns in ascending or descending order. And for filling data based on conditions to extract relevant information. And for combine sorting and filtering techniques to perform complex data operation, the sorting and filtering are used. And for grouping and aggregating data, group students data based on a particular attribute such as semesters will be coming. And performance aggregating functions like sum, mean, or count within each groups. And to analyze trends and patterns by grouping and summarizing data. And for combining data sets, merge multiply students database to create a comprehensive dataset. Use keys to join data frames based on common attributes, and choose an appropriate merge technique such as inner, outer, left, or right join. And for data cleaning, identify and address inconsistencies or errors in student records, and standardize data formats, correct typos, and remove duplicates. Ensure data quality by validating entries and maintaining accuracy. And for the performance optimizations, improve the efficiency of data operation by optimizing code. And for utilize pandas functions and techniques like vectorization to enhance performance, and monitor and analyze the execution time of data processing tasks. And error handlings, implement error handling mechanisms to handle exceptions during data processing. Use try expect blocks to capture and manage errors gracefully, and provide informative errors message to aid in troubleshootings. And to security and privacy, secure student data by implementing access control and encryptions, and follow best practices for data privacy to protect sensitive information, and regulatory audit and review data handling process to maintain security. To access control implementation, the prevention of authorized use of a resource. The prevention of use of a resource is an unauthorized manager, and assignation of access right to certain resources on systems, and it is used in environments where information classifications and confidential is very important. And for scalability and flexibility, design the student database to accommodate future growth and changes, and to use modularly and extensible code structures to adapt to evolving requirements, and consider the scalability factors such as data volume, performance, and user requirements. And the best practices: follow coding conversation and documentation standards for maintaining code, and to test and validate data processing functions to ensure accuracy and reliability, and to collaborate with stakeholders, gather feedback and improve the student database. And conclusions: creating a student database using dictionaries and pandas data frames in Python offers a versatility and effectiveness solutions. The database allows for effective management, analysis, and visualization of student information. By following best practices and pandas functionalities, the student database can be a valuable tool for education institutions. Hello viewers, welcome back to my YouTube channel. In this video I am going to discuss about the fabrication process in VLSI and the introduction to VLSI fabrication process. VLSI involves the creation of integrated circuits with millions of transistors on a single chip. The fabrication process in VLSI plays a crucial role in determining the performance and functionalities of electronic devices. It involves a series of steps to create the intricate patterns and structures on a silicon wafer. And the silicon wafer preparation. The fabrication process begins with the preparation of a silicon wafer, typically made from a single crystal silicon ingot. The wafer is polished to achieve a smooth surface and then cleaning to remove any impurities. A layer of silicon dioxide is often grown on a wafer to serve as a insulation layer. And the photolithography is a key step in fabrication process where patterns are transferred onto the wafer. A layer of photoresist is applied to the wafer, exposed to light through a mask, and developed to create a pattern. This pattern defines the location of the various components on. And etching is used to selectively remove materials from the wafer to create the desired patterns. There are too many types of etching: wet etching, which use liquid chemicals, and dry etching, which uses plasma. Etching is crucial for define the shapes and dimensions of the components on the chips. And the next deposition is the process of adding thin layers of materials onto the wafer. A common deposition technique includes chemical vapor deposition (CVD) and physical vapor deposition. It's also called PVD. Deposited materials can include metals, insulators, and semiconductors. And the ion implantations. Ion implantation is used to introduce dopants into the silicon wafer to alter its electrical properties. Dopants are ions of specific elements that are implanted into the wafer at precise locations and depths. Ion implementation is essential for creating the transistors and other electronic components on the chips. And the metallization involves deposition metal layers on the wafer to interconnect the various components. Metals such as aluminum, copper, and tungstens are commonly used for interconnects, and the metallization is crucial for creating the conductivity pathway that allows signals to flow between components. And the planarization is the process of creating a flat surface on the wafer to ensure proper layer to layer alignment. Chemical mechanical planarization is a common technique used to achieve a smooth and uniform surface. Planarization helps to improve the reliability and performance of the integrated circuits. And the annealing is a heat treatment process used to activate dopants and repair crystal damage and relieve internal stress in the wafer. Rapid thermal annealing and furnace annealing are two common annealing technique used in VLSI fabrication. Annealing is critical for ensuring the proper functioning of the transistors and other components of the chip. And the inspection and testing. After the fabrication process is completed, the wafer undergoes inspection and testing to ensure quality and functionality. Various techniques such as scanning, electron microscopy, and electrical testings are used to validate the integrity of the chip. Defective chips are identified and discarded during this stage to ensure only high quality products are shipped. And the packaging, once the chips are deemed functional, they are packed to protect them from external elements and provide electrical connections. Packaging involves encapsulating the chips in a protective material and adding LEDs for external connections. The packaged chips are then tested again before being shipped to customers. And the advancement in VLSI fabrication, advances in technologies and has enabled the fabrications of smaller and more complex integrity circuits. Techniques such as extreme ultraviolet lithography and 3D integration have pushed the boundaries of VLSI fabrication. These advancements have led to faster, more energy efficient, and higher performing electronic devices. And the challenges in VLSI fabrications, managing the increasing complexity of fabrication process requires advanced simulations, modeling and control techniques. VLSI fabrication also faces challenges related to cost, time to market, and environmental impact. And further future trends in VLSI fabrications, the future of VLSI fabrication is likely to be driven by technologies such as artificial intelligence, IoT, and quantum computing. The industry is expecting to continue innovative to meet the growing demand for faster, more efficient, and secure electronic devices. And conclusion, the fabrication process in VLSI is a complex and intricate series of steps that enable the creation of advanced integrated circuits. Continuous innovation and advancement in technologies are driving the evolution of VLSI fabrication. Understanding the fabrication process is essential for engineers and researchers working in the field of semiconductor technologies.